Hello, hello, hello. I think your audio is not connected. You have to check your mic.
Hello.
Yeah, can you hear me?
Yes.
Okay, so we'll start with the paper which is 2022 November 10th.
Yeah.
Did you get a chance to try this?
Yes.
Okay, so any geometry problems that you didn't get?
Um, so for that one, I needed help on problem 25.
One second.
Yeah.
The question is just saying RST.
One second. Yes.
Let RST be squares that have vertices at lattice points. Lattice points are points whose coordinates are integers in the coordinate plane together with their interiors. Excuse me. The bottom edge of each square is on the x-axis. Okay. The left edge. Okay. Is there a figure draw? Okay. Figure is given. Fine. The left edge of R and the right edge of S are on the y-axis. And R contains 9 by 4 as many lattice points as does S. Okay. The top two vertices of T are in R union S, and T contains 1/4 of the lattice points contained in R union S. See the figure. Okay. The fraction of lattice points in S that are in S intersection T is 27 times the fraction of lattice points that are in R intersection T. Minimum possible value of the edge length of R plus the edge length of S plus edge length of T. Okay. So first of all, we have to understand the figure. It is, there are three squares and one of them is like this. This is R. Then another square is like this. This is T. And one square is S, which is like this. Y-axis, x-axis.
Yeah.
Now, they have told us in the problem that RST are squares with vertices at lattice points together with their interiors. Okay, bottom edge is on the x-axis, fine. Left edge of R and the right edge of S are on y-axis. Okay, So the figure that we have drawn is correct only. Left edge of R, right edge of S. Fine. Now information that they have given is R has 9 by 4 number of lattice points of S. Okay. And top two vertices of T are in R union S. And T contains 1 by 4th of lattice points in R union S. R union S. So the top two vertices are inside the union, and T contains 1 by 4 of the lattice points of R union S. Right?
Yes.
Okay. Uh, Fraction of lattice points that in S that are in S union intersection T. The fraction of lattice points in S that are in S intersection T. Okay. 27 times. Okay. So lattice points in S in intersection T. Number of lattice points there is 27 times the number of lattice points that are there in R intersection T. Right?
Yeah.
Fine. We have to find the minimum possible value of edge length of R. Okay. Add all the edge lengths and we have to find the minimum of that sum. Minimum of R plus S plus T, the edges. Let's call that small r, small s, small t. We have to find minimum of R plus S plus T. Right?
Yeah.
So now, first of all, we know many things about the squares R and S because they told us that they lie on the y-axis, the one of the edges, right?
Yeah.
So if this point is 0, 0, we know this point is R comma 0. This is R comma R. This is 0 comma R, right?
Right.
And this point is 0 comma minus S. This is S comma, no, this point is minus S comma 0. This is minus S comma S. This is 0 comma S.
Yeah.
We don't know where the T is, but we have to find out the length of T and we have to find out this value. Okay. We
Yes.
have this data. So number of edges, number of lattice points in R is 9 by 4 times the number of lattice points in S. So that should give us an indication of the ratio of the R and S, right? So
Right.
how do we count lattice points? There are there are going to be several of these lattice points which are on the x-axis, then many of them here, many. Just have to figure out a formula for lattice points. So let's take a square which is of length 2 units, right?
Yeah.
If you make a square like that, 2 units, you'll have 3 lattice points here, then 1 here, 2 comma 1, 2 comma 2. So 5, 1 here, 7, and 1 here, 8, right?
Yeah.
8 are on the edges, and then there will be some inside, right? So
Yes.
basically, there will be only one inside, actually, right?
Yeah.
So there is 9 lattice points in this figure. This is the point 1 comma 1. We have already counted every other point.
Yes.
If it was a 3-unit thing, we need a pattern. So you have to figure out the pattern. If it was a 3-unit thing, you have 9 in this, and then after that you have 10, 11, 12, 13, 14, 15, 16, right? So it's a clear pattern. Do you understand what I'm saying?
Yes.
when you have a 2 square, you have 9 lattice points. When you have a 3 square, you have 16 lattice points. So
Right.
the number of lattice points in R is how much? R plus 1 whole square.
Yes.
That is 9 by 4 of S plus 1 whole square, right?
Yeah.
Okay. And here we get T plus 1 whole square is 1 by 4 of number of lattice points in the union of R and S, right? So that's going to be the sum of R plus 1 whole square plus S plus 1 whole square, but we have to subtract the common ones.
Right.
Do do you understand what I'm saying?
Yes.
The common ones are going to be counted twice, so we need to subtract them. So, okay, so from here 0 comma 0 to 0 comma S, there are S plus 1 lattice points,
Yeah.
right? So we need to subtract them once because they will be counted twice otherwise.
Correct.
So we have several relations now. We have T plus 1 whole square is equal to 1 by 4 times R plus 1 whole square plus S plus 1 whole square minus S plus 1, right? This is the second relation.
Oh, yeah. Right.
This is the first relation. So R plus 1 whole square can be written like this. So we can basically eliminate every R from here. We can write
Yeah.
it as 9 by 4 S plus 1 whole square. 9 by 4 plus 1 by 4 by 4. So 13 by 4 S plus 1 whole square minus S plus 1 multiplied by 1 by 4. So I'm getting 13 by 16 S plus 1 whole square minus 1 by 4 S plus 1. That is equal to T plus 1 whole square, right?
Yes.
Okay. We have this equation which we have used, and now we have this equation. From this equation, what can we say? We can multiply by 16 everywhere. 13 S plus 1 whole square minus 4 times S plus 1 minus 16 times T plus 1 whole square is equal to 0, right?
Yeah.
This is a quadratic equation in the variable S plus 1. We also know that S and T are integers, so that should be handy at a later stage. But this is a quadratic in S plus 1. So what I can say is I can solve for S plus 1 and get it in terms of the T plus 1, right?
Yeah.
Do you understand what I'm saying?
Yes.
Okay, so let's try that. We will get S plus 1 is equal to negative of B, so 4 plus minus root over b square 16 minus 4 into 13. Okay, so plus 4 into 13 into 16 t plus 1 whole square whole divided by 2 into 13. You can take a 4 common from here and that will come out as a 2. You will get 2 plus minus root over 4 plus 13 into 16 t plus 1 whole square divided by 13, right?
Yeah.
We can't use the minus sign because that will make it negative. So S plus 1 is basically going to be the plus option here.
Yeah.
Okay. Also, S plus 1 has to be an integer. We know that. So this thing somehow should work out to be an integer, right?
Yeah.
It should be a perfect square somehow. Also, it should be divisible by 13, which is an important thing. So great. So a lot of information is here. So first of all, we will write the first relation that we had was t plus 1 whole square and all, no? That relation was there already. R
Yeah.
plus 1 whole square was 9 by 4 times t plus 1 whole square, right?
Yeah.
No, s plus 1 whole
No,
square.
S plus one. Yeah.
R plus 1 whole square is 9 by 4 times s plus 1 whole square. So this relation is there. And now I have a relation like s plus 1 is equal to 2 plus root over 4 plus 13 into 16 t plus 1 whole square divided by 13, which means that somehow this part should become a perfect square and should be such that s plus 1 comes out as an integer. So what can we conclude from here? Right. We have not yet used the other conditions, which are this condition, the third condition, intersection ones. So S intersection T has number of lattice points is 27 times R intersection T. And top T plus 1 whole square is 1/4 of. With that, we have already used. So only one condition is left which we have not used. This one, right?
Yeah.
S intersection T has 27 times the number of lattice points of R intersection T. So let's think about that for a moment and figure out how to find out S intersection T number. So they are comparing S intersection T and R intersection T. Okay, so S intersection T has 27 times R intersection T. That means the total is 28 times R intersection T. The total number of lattice points in T, right?
Yeah.
Think about it. Total number of lattice points in T is how many? It will be the part that is S intersection T plus the part that is R intersection T, right?
Right. Yeah.
There is no other part there, right? So we can say that it is total 28 times R intersection T, right?
Yes.
So all we need to now do is count R intersection T. That is should be equal to this should be equal to T plus 1 whole square, right?
Right.
Do you understand what I'm saying right now?
Yes. Yeah.
So then we need to get an expression for this R intersection T part. So let's think about it. It's the pink part to the right side of the y-axis, right? So, okay. The minimum value of it. I still have to use somehow the fact that these are integers. I've not yet done anything about that. So that also we have to think of. Uh, right. So, okay, let's use the fact that here, from here, we can say r plus 1 whole square by s plus 1 whole square is equal to 9 by 4. So what we are getting is r plus 1 by s plus 1 is 3 by 2, right?
Yeah.
Okay, so the ratio is this, so we can call it 3k and 2k. This is basically r plus 1 and s plus 1, where k is some integer, right?
Right.
Then s plus 1 is 2k and r plus 1 is 3k. Okay. From here, what can we say? So we can just put our, maybe we should have done that only in the beginning. Okay. I have complicated it too much. So what we are saying is r plus 1 whole square by s plus 1 whole square was 9 by 4, right? So from here we got r plus 1 by s plus 1 is 3 by 2, right?
Yeah.
And we can say r plus 1 is 3k, s plus 1 is 2k. This is the first piece of information. And we are going to use 3k and 2k from now on later. Okay.
Okay.
The second piece of information was about the equation that we made. We made an equation about the R union S part, right?
Yeah.
So we said that T has one fourth of the lattice points contained in R union S. So T's lattice points are T plus 1 whole square. That is going to be one fourth of the lattice points in R union S. We saw that that was R plus 1 whole square plus S plus 1 whole square minus S plus 1. Correct?
Yes.
So that will become 1 by 4. Now I'll put the 3k and 2k here so that I get an idea of t plus 1 in terms of k also, right? So that is
Yeah.
what I should have done first. I am making it more complicated if you don't use this initially, right?
Right.
So here you will put 9k square plus 4k square minus 2k. So we are getting one fourth of 13k square minus 2k, right?
Right.
So that is t plus 1 whole square. So we are getting t plus 1 is equal to root over 13k square minus 2k divided by 2, right?
Yes.
Now this has to be a perfect square, right?
Correct.
Okay.
Yeah.
So let's think of how we can simplify this. This is a number theory problem now. So let's say that this is an integer. So we have, let's call this, for now, we can call it y. So we can say 2y is equal to this. What are we calling y? Y is t plus 1 for now.
Yeah.
So we are getting 4y square is equal to 13k square minus 2k, right? What can we do with that? Uh, okay. Okay, so we can now look at, this is like a number theory problem. We have to figure out something from here. So think about it. The left hand side is even, right?
Yeah.
The right hand side has to be even then, right?
Right.
But the second term here is even, right? So this term also has to be even.
Yes.
So we know 13k square has to be even, means k square has to be even, right?
Right. Yeah.
If k square is even, that means k is even.
Yep.
And if k is even, we can write as k is equal to some 2p for now, right?
Yes.
Okay. So we'll put that. Uh, We'll put that k is equal to 2p in the same equation. So that will help us because now you'll see what will happen. So we will get 4y square is equal to 13 k square. K is 2p. So k square is 4p square minus 2 into 2p. So 4p. So we are getting y square is equal to 13p square minus p, right?
Yeah.
Where p is some integer.
Right.
Okay. So, right, let's think of this. So y square is equal to p common 13p minus 1, right?
Yes.
Fine. Uh, how can the product of p and 13p minus 1 be y square? Hmm, hmm. Okay, we can think of this as a quadratic in this and say that p is equal to 1 plus minus root over 1 minus minus plus 4 into 13y square. So 52y square by 26. But p is supposed to be an integer. So this part is a perfect square. So 52y square plus 1 is a perfect square. Let's check some values. When can it be a perfect square? If you put y is 0, you get that one case, but that is not allowed for us. So if you put y as 1, uh, you're not getting it. Y is 2, 52 into 4, 208 plus 1, no. 52 into 9 plus 1. Uh, how can we get a perfect square from it? There is something that we are missing. Feel like um, is there any perfect square that you can think of that comes fits this pattern? That's what I'm thinking. So 256 you can't do. Before that you can't do 25 also, right? No. 196, no. 169. No. So 52 into 9 is what? 450, 468, 469, right? That doesn't work. 52 into 16, 16. 10 the 520, 260, 780 plus 52, 932. Doesn't work. We are missing something because this also seems too long. Here, what can we say from here? Y square is equal to this. P and 13p minus 1 are relatively prime. They have no common factors. You can take any integer p, 13p minus 1 is not going to have a common factor with it. Right? Because if you notice, think of it modulo p. This is always minus 1 modulo p. This is 0 mod p. These don't have any common factors. So if the product of these two things is going to be y square, then each of them must be a perfect square. Each of them must be a perfect square, then only the product will be a perfect square because they don't have common factors, right? You can take any number. I don't think you will be able to find a perfect square set up here. Uh, we are missing something. I will try it out and let you know. We cannot spend so much time on one question for now. But other than this 25 before this, tell me, is there any other question?
Oh, yeah, I forgot to say before. I needed help on 23 as well.
Isosceles trapezoid ABCD has parallel sides AD and BC with a, okay, BC is less than 80, right? So isosceles trapezoid, so the side lengths are equal, the non-parallel sides.
Yeah.
A, B, C, D. AD and BC are parallel. They have said BC is less than 80, that's fine. And they have said AB is equal to CD. And then there's a point in the plane such that PA is 1, PB is 2, PC is 3, PT is 4. PA is 1. Okay, so somewhere here, let's say, okay, PA is 1, PP, PC, and PT. The distances of P from everyone is given. Okay, 1, 2, 3, 4 are the distances. We have to find out PC by 80.
Yeah.
Okay. Uh, these lines are parallel BC and AD, and right. Okay, so one easy way to do it is to label all the points nicely. So, for example, uh, let's say let's say somewhere here is my midpoint 0, 0. This is minus a comma 0. This is a comma 0. The midpoint of AD is my origin. Okay. So in that case, you can say this will be negative side of the y axis, right? For
Right.
example, you can say this will be at minus b comma h, let's say. This would be at b comma h, right? Do you understand why the other one would be at b comma h?
Yeah, because
Because
it's
it's
a
an isosceles trapezoid.
yeah.
Because we have divided this into half, this will also be divided by half by the same line, right?
Yeah.
Okay. Now, what we can say is, let's say the point P is x comma y, right?
Yeah.
Now, what I have is some equations I can make, which are like basically distance formula equations. Because I know four distances, right?
Right.
I can say this distance is 1. So I can say x minus minus a. So x plus a whole square plus y square is equal to 1, right?
Yes.
Then from here and here PB, I can say x plus b whole square plus y minus h whole square is 4. From
Right.
PC, I can say x minus b whole square plus y minus h whole square is 9. And from PD, I can say x minus a whole square plus y square is equal to 16, right?
Yeah.
Our job is to find BC by AD, which is actually 2B by 2A, right? Our job is
Y-
to find simply the ratio of B by A, right?
Right.
From these equations, basically, we need to eliminate which variables? X, Y, H.
Yes.
It is possible to eliminate because what we will do is we will take this equation and this equation and subtract them. If you subtract them, what will happen? You will remove the y square, right?
Correct. Yeah.
If you subtract this equation and this equation, we'll get 4xa is equal to minus 15, right? And you subtract these two equations, you will get 4xb, and nothing will be left here, no? So it will totally go. Is
Yeah.
minus 5, right? The question is over now. You can take the ratio now, no?
Correct. Yeah.
You will do 4xb by 4xa is
Yeah.
minus 5 by minus 15. You will
Hmm.
get b by a is 1 by 3.
Right. Yeah.
So that is one way to do it. The main thing here is choosing the correct coordinates. Choosing
Right.
the right coordinates. And if you choose the right coordinates, the question is easy. If I had chosen randomly this as 0, 0, right?
Yeah.
Then it would be slightly annoying, right?
Right.
What I
Yes.
chose is this as 0, 0 and this as midpoint. Midpoint of AD is the 0, 0, which will also intersect the midpoint of BC, right?
Right. Yeah.
There could be other ways to do this problem. Uh, what else could we do?
Um.
1 second. You should try to think of other solutions also. but I think it will always involve this perpendicular bisector. So without thinking of this perpendicular bisector, I don't think it is very easy to solve. Uh, okay. Okay, right now I can't think of any other solution, but yeah, there is possibly a geometry solution. So right now what we did was coordinates, right? So that is like a nice way to do it, but there could be other ways to do it also. What about any other problems before?
No, not in this one.
You tried only the geometry ones or others one also? Others also.
Only only the geometry ones.
Uh, did you do question 13,
Uh, question 13. One sec.
13 and 15?
Oh, I missed 13. I didn't see it. I did 15 though.
15 is fine.
Yeah.
13, try it out right now.
Okay.
AP bisects angle BAC. The line through B perpendicular to AP. Line through B perpendicular to AP. Intersects the line through A parallel to BC. Line through A parallel to BC. So this line, these two lines intersect here. This point is called D, I think. Suppose BP is 2 and PC is 3. BP is 2 and PC is 3. You have to find out AD. Okay. This line is parallel to the base, right?
Right, yeah.
And this was a bisector. So first of all, by angle bisector theorem, we know some things, right?
Yeah, you know that AB times 2 is equal to AC times 3.
We know AB by AC ratio is 2 by 3.
Yeah.
Okay. Then this is a perpendicular line like this drawn which intersects here. So okay, we have to find AD length. So parallel lines we have to use. We can say this angle is equal to this angle, right?
Yes.
And we already know these angles are equal. So the
Right.
triangles are clearly similar, right?
Yes.
Let's call this point E. The triangle AED is similar to BEC, correct?
Correct.
So then uh, we also know this angle is equal to this angle.
Yeah.
So this length is 5. Okay, so we can say ratios of the sides will be equal, and therefore we can say AD by 5 will be equal to AE, which is opposite to this, and in this triangle it is EC. So AE by EC is equal to DE by BE, right?
Yes.
Okay. So we need one of these ratios, either AE by EC or DE by BE, right?
Yeah.
If you can find these ratios, then AD is coming automatically. So let's think of how we can find the ratios AE by EC. Uh, 1 second. Look at triangle ABE.
Yeah.
In triangle ABE, this line
Mm-hmm.
is the bisector and it is also perpendicular, right?
Right. Yeah.
Angle bisector is perpendicular. So this is basically isosceles triangle. Why? Because the altitude is also an angle bisector, right?
Right. Yeah. Yeah.
We can prove congruency.
Yes.
So we get ABE is isosceles from here. That means AB is equal to AE, right?
Yeah.
And therefore it is also equal to AC, right? Correct? No, no, not AC. Uh, we know AB and AC ratio, right?
Yeah.
So we know that AB is 2 by 3 AC, correct?
Yeah.
Is equal to AE, right?
Correct.
So now we are getting the ratio of AC and AE. Now it's over. We're getting AC by AE is equal to 3 by 2.
Right.
And AC is what? AC is AE plus EC
Right. Yeah.
divided by AE is equal to 3 by 2. So we are getting 1 plus EC by AE is equal to
Yes.
3 by 2. So EC by AE is 1 over 2. So
Right.
AE by EC is 2.
Yes.
So AD is 10.
Right. Yeah.
So the point is that everything is fine. The basic things are angle bisector theorem, then obvious similarity, right? Because
Yes.
these lines are parallel, there is an obvious similarity. You should always write this ratio, which will at least tell you that all we need is this or this.
Yes.
And then the only thing that is left that you need to utilize in the question is basically what can we do about this perpendicular stuff?
Right. Yeah.
So you have to utilize the fact that it was angle bisector, perpendicular, then you think about it, then you can prove this congruency here.
Yes.
Do you understand what I'm saying?
Yes.
It is already similar because of two angles and there is a common side, so it is congruent. If it is congruent, then this is equal to this.
Right. Yeah.
Once you know that, everything is done because you know the ratio of AC and all, AC and AB.
Yes.
You need to try more questions, especially like don't skip any questions. Actually, the questions are quite a good standard, so you can't skip anything, and you should do the rest of the paper also, not just the geometry questions. Try, for example, look at question number 6 in this paper only. Do you know how to do that?
Yes. Question number 6. Yes.
Tell me what
Oh,
should I do?
wait, let me look at it. Which expression is equal to where a is greater than 0? Oh, less than 0, sorry. Mm,
The main thing is the basic definition. How should we handle this thing, right?
right. So
Square root of x square. How should I write that?
square root of x squared. Oh, x.
No, it's not necessarily x, it's mod x. Why am I saying mod x?
Oh, because we're looking for the positive value.
Square root of x square could have happened even if you do minus 4 square. That is also going to give answer of 4 only.
Yeah.
How can it become 4 then? When you are done minus 4 whole square. You can't
Oh,
write x.
right. Yeah.
You have to write mod x because if the value is negative, then you have to do negative of that.
Yes.
The point is that whenever you have this thing, you can't just write it as x, you have to write it as mod x. So therefore here I have to write a minus 2 minus square root of a minus 1 whole square is going to be mod of a minus 1,
Right.
right?
Yeah.
Now you have to look at this and decide what will happen. When a is less than 0, a minus 1 is clearly going to be negative, right?
Yes.
So how do you open that mod here?
You do a plus 1.
What? No.
Like,
How can I do a plus 1?
well,
What is the
because,
definition of mod?
like,
Modulus of x can be written as what in what case? You know this absolute value sign, what it means?
Yeah, it's like the distance it is from zero.
What is the algebraic way to remove the absolute value sign? What should I write here?
Um, multiply by,
You don't know the definition of modulus, that's why you can't do this. This is a very basic thing, you need to know it. So remember what I'm telling you right now. We
yes,
will not be discussing it again. Just pay attention. Modulus of x is always x if x is greater than equal to 0 and is minus x if x is less than 0.
right,
If that x thing inside the absolute value was negative, the modulus will be minus x. So
yes,
that the answer comes out was positive.
yeah,
If it is positive, you will keep it as it is.
right, yeah,
But if you don't know this definition, you can't solve problems. Here you have to use the definition. Because we had a less than 0, we know that a minus 1 is less than 0.
right,
That automatically means that mod of a minus 1 will come out with a negative of a minus 1, not just a minus 1.
yes.
Which becomes what now?
Oh, negative a plus 1.
This is what is coming, 1 minus a.
Yeah,
We'll say that this is minus 1 minus a,
yeah,
right? So this becomes mod of 2a minus 3, correct?
correct.
If a is less than 0, obviously 2a minus 3 is also less than 0.
Yes,
So finally, again applying the same definition of mod, this is 3 minus 2a.
right, yeah,
But anybody who doesn't know the definition of mod can never get this right, even though it's actually a very easy question.
right,
The geometric meaning of modulus is useful, but not useful here. This is an algebra question. You need to be able to simplify the modulus and remove it.
yes,
Do you understand what I'm saying?
yes,
It's a conceptual question which checks whether you know the definition or not. Similarly, for example, question number one sec. By the way, if you see question 17 is very similar to the questions that we have done in number theory recently.
question 17. Oh, yeah,
There are three-digit integers that they're asking which satisfy certain things.
yes,
We have tried out questions like that. You need to be able to handle it.
yeah,
Let's look at the question. There is not too much algebra. There is algebra which is hidden in the other questions. Okay. For example, 20, question 20, if you see,
yes,
a four-term sequence is formed by adding each term of a four-term arithmetic sequence of positive integers to the corresponding term of a four-term geometric sequence of positive integers. Okay. Do you know what arithmetic and geometric sequences are?
yes,
Okay. So what they are doing is they are making a new four-term sequence by adding each term of AP to similar term of a GP, right?
yes,
Okay. First three terms of the resulting four-term sequence are these three. What is the fourth term? So fine. So they have given you three terms 57, 60, 91.
yeah,
This is the final series after adding. You have to figure
right,
out what is the fourth term, right?
yeah,
So if my AP was A plus D, A plus 2D, A plus 3D, my GP was BR, BR square, BR cube. right?
Yeah.
This is an arithmetic sequence. This is a geometric sequence. Do you understand what I have done?
Yes.
My terms are a plus b is 57 and a plus d plus br is 60 and a plus 2d plus br square is 91. And from there we have to find out this, correct?
Correct.
Okay, so right. So what I will do is I will not do it like this because this is making annoying equations, right? These are
Right.
not great equations, these are annoying equations. So
Yeah.
what I will do is I will choose my AP terms nicely. Uh, let's choose it in a slightly cleverer way. So we need four terms in AP and four terms in GP, right?
Right.
Okay, so what I will do is I'll choose my AP terms like this: A minus 3D, A minus D, A plus D, and A plus 3D. And then my GP is B by R cube, B by R, BR, BR cube. Maybe this will help. I could have ignored the fourth term and just done a different choice also. The different choice would be just to make these simpler. So that could have been done like this also. A minus D, A plus T, A minus D, A plus T, and A plus 2D. This is also possible.
Yeah.
The point is to cancel some D's if you have to add.
Right.
And I could have chosen like this also: B by R, B, BR, BR square,
Right.
right? Let's
Yes.
see what is going to be more useful. So we have this plus this is 57, this plus this is 60, and this plus this is 91.
Right.
Uh, maybe this is better. This choice is better. It is simpler.
Yeah.
So I'll say A minus D plus B by R is 57. A plus B is 60. And A plus D plus BR is 91. Right?
Right.
These equations are quite good. If you add these two, you will cancel the D. You will get 2A plus B by R plus BR is equal to 57 plus 91, right?
Right. Yeah.
So that becomes 148. That is one equation. And 2A plus B by R and BR. Okay, and A plus B is 60. Where can we use that correctly? So, okay, what I need is A plus 2D plus BR square. So, A plus 2D plus BR square, okay. We have added these two. We can also, can we eliminate something? Second. We are not yet thought about the fact that everything has to be an integer, right? Uh, that has to be used here. They have said that the GP is a GP of integers. It cannot be a fraction or something.
Right, yeah.
So we have to use that also. 2a plus b by r plus br is 148. So maybe this approach won't work because the equations are quite complicated. Maybe we should use the simpler approach where at least the equations didn't have fractions. The first one only that we were doing, right?
Yeah,
But the point is that the questions are not super easy or something. You have to try a little bit, right?
right, yeah,
So as soon as you get to around 20 or something, the questions are becoming quite tricky.
yeah.
So what is the qualifying score like in AMC?
Wait, I can search that up. I don't know
Like,
exactly. I think it
did you,
changes every year. Like there's the top some percent that goes forward
so what
to
is
like
a good score that you need? Roughly, you have an idea?
I'm sure it's like 100 something,
Each question
probably.
has different marks.
No, I all of them are
It should have different marks though, right? Because questions are much harder at the end, right?
I think they're all the same marks.
Okay, okay,
Or
fine.
like
But I think
like
you'll have to do 15 or more, I think, right?
yeah, because correct answers are like 6 points and unanswered are 1.5, but incorrect are 0 points. And the total score you can get is 150. So I think
But
you have to like an AME qualifier would be like 105 around that, or like 100 something.
so find this out, okay, what you need to get to the next stage. So that will
Yeah.
help you understand like how many questions you actually have to attempt. So obviously the first questions are not as hard as the last question. So if it is equal marks, then obviously we should make sure that you spend the time more on the easy ones, right?
Yeah.
What is the time limit?
75 minutes.
75 minutes, huh?
Yeah.
Okay, that's a small time interval. So 75 minutes, that means you have to maximize the questions that are easy.
Yeah.
So then it's a test of speed also, not just like doing.
Yes.
Okay, so fine. So then we need to like seriously practice a lot of these papers and do the full papers, try and see which questions are doable, how many are doable for you. Like you need to
Mm-hmm.
analyze that how many are you able to do right now, and we can work on the ones that are not coming. We can see, and ultimately now the exam strategy will depend on this time factor. So you have to think about that also.
Right.
It is better to do two easy questions rather than one hard question, right?
Right. Yeah.
So basically the choice becomes very important. So you should like if the exam is 75 minutes, there is no chance that you can attempt question number 25 in the paper.
Right.
Question number 25 is doable, but we are stuck still. It is not done yet, right?
Correct. Yeah.
There is some stuff there that we have to figure out. It is a normal question which could come in an actual Olympiad where you will spend enough time on it and do it. But
Yeah.
it can definitely not be done in a 75-minute test.
Right.
So you should realize that, okay, this question is too complicated to try also, and you save your time and do others.
Right.
Okay. So what I want you to do is every week, two, three papers you have to do. 2 to 3 papers you have to finish.
Okay. Yeah.
Don't just focus on the geometry part. Geometry part is good. We have to try that anyway. But these three PDFs that I've sent, I think they have two papers each, I think, right?
Okay, yeah, right.
There is one more paper below in the same document.
Yeah,
So what I want you for this week, finish all of the papers, try every question, see what is there, how much score you are able to get right now. Like
okay.
we need to do this exercise at least for 2 or 3 weeks, and then we will have a much clearer picture of what is exactly your strength and what we should work on immediately.
Yes.
So do that, and we will analyze our results after maybe a month of practice of these actual papers.
Okay, yeah.
Thursday's class will be number theory as usual, but right
Mhm.
now focus on trying as many papers as possible here. The three documents that I have given, try to finish every question by next week, okay?
Yes. Okay.
And see what you're able to get.
Yeah. So, do you want me to do like all the questions and not just the geometry, like every single one?
Yeah, you have to
Okay.
do it in the exam, no?
Yes. Okay.
We have to find out what our strengths are, what our weaknesses, which questions are doable, how many are doable, what is the general paper strength, right?
Right.
We have to do that. Only by doing everything you will understand that.
Right.
So work on it, these three documents. After that, we'll do more papers. Ultimately, we have to figure out what we need to do next. So only by doing
Yes.
the actual exam papers, you can figure out what is your weakness.
Correct. Right.
Okay, fine. That's all for now. I will see you on Thursday then.
All right. Thank you.
Mhm. Bye.
Bye.